If I put in 1x and I get out more than 1y, I know it's not a function. I want to stay away from numbers like 0 and 1 because sometimes it can give us a wrong thing. So I'm just going to pick a number. Here the problem tends to be if I put an x value in and I'm going to solve for y, it can't be too much of a positive x value. Why is that? So if I put in a positive 3, what's going to happen when I solve for y? I'd end up with a negative on this side, and I'd end up with imaginary numbers, right? So I'm going to put in a negative 3 for x. Suppose x equals negative 3 plus y squared equals 1. Add 3 to both sides. Y squared equals 4. Now, this is where some of you guys really make mistakes because you're used to seeing the square root property. But if I'm going to use the square root property, if I take the square root of both sides, what must I remember? Not to forget. The plus or minus. So this says that y is plus or minus 2. So that says negative 3 goes to 2. But negative 3 also goes to negative 2. So is this guy a function? No. Now, an easy way to see that is because you have a y squared. So if you have an even degree it wouldn't be degrees at this point. If the y basically are in even powers, then you know that it's not going to be a function. It's going to fail the vertical line test. Not vertical line test. It's going to fail because when you take the square root of both sides, you take the fourth root of both sides, what's going to happen? You have to have a plus or minus. So if there's a squared thing in it, no. Y squared is going to lead to non-entities. Now here, if I put in a number and doesn't matter what I put in, so x equal 3. I like positive things if possible. What's y? Y is 3 times 3 minus 1 over 3 plus 2. 9 minus 1 is 8 divided by 5. So 3 goes to 8/5. Is that a function? Yes. Oh, I'm sorry. Thank you. So 3 goes to 8/5. So is it a function? Yes. And you also notice what's y. y2 is to the first power. Doesn't matter what x is to. It's all y. It's all y's fault. Even though x is in charge. Strange, huh? Yes. So yes, it is a function. Domain. And those of you who have been my students, we've seen this dozens of times before. You're going to see it again this semester. And domain, the domain of a function. I've lost it. There it is. The domain of a function is all real numbers, and that's the pot. Imaginary numbers need not apply. They're not part of this domain. It's all real numbers, except we have 2 cases. The denominator can't be 0. So in other words, the function has to have a denominator. If it does not have a denominator, then this rule doesn't apply. And if you remember, then the radicand must be greater than or equal to 0 for even indexed radicals. Radicand The radicand is the thing that's under the radical. That's what the radicand is. So it must be positive for even index radicals. Now, what does that mean? That means if it doesn't have a denominator and if it doesn't have a radical in it, what's the domain? All real numbers. Because it doesn't have any problems. The only two problems it could have is if it has a denominator or radical. No denominator, no radical, all real numbers. So if I look at number 48, what's his domain? All real numbers. He doesn't have a denominator, right? Nope. Doesn't have a radical, right? Nope. And so his domain is all real numbers. And an easy way to write all real numbers is a double bar R. And that stands for all real numbers. So instead of putting, writing out the words all real numbers, just put this symbol, and that means all real numbers. Now, what do you notice about this guy? He has a denominator. So what do we know? The denominator, whatever the denominator is, this sets up your it's like having a word problem. It sets up your equation. The denominator can't be 0. The denominator is x squared minus 4. It can't be 0. Follow the signs down, because that's my denominator. I don't care what the numerator is doing. This is the difference of squares, so x minus 2, x plus 2 can't be 0. X can't be 2. X can't be negative 2. That's my exclusion. You'll find in this class after a while this is how you'll write it. But if you just write x can't be 2, x can't be negative 2, or x can't be plus or minus 2, that's a sufficient answer. But like I said, by the time you're finished with this course, you'll probably write it this way. Some of you, and this question hasn't come up yet, are used to writing it in interval notation. If you want to do that, be my guest. It's just, to me, it's too much work. Interval notation would say I have to exclude, if you think about the number line, that's minus infinity to plus infinity. You need to exclude 2. You need to exclude minus 2. But it's everything except those two numbers. So if you want to write an interval notation, it would be minus infinity to, not including, union, not including, to negative 2, not including, union, negative 2, infinity. And that's another way of writing it. But to me, that's a pain. That's quick, and I don't have to worry about anything. Will we use intervals? The answer is yes. You'll find you'll use them a lot in Chapter 3, but they're going to be in a different context.